This episode is brought to you by DAS London, Blockworks' #1 institutional crypto conference where all the top institutions and people in crypto are going to be this March in London, what's becoming maybe the crypto hub of the world. I have a link in the show notes where you can learn more and also a discount code that will get you 20% off. So click the link, find out more, and I'll see you there. What's up, everybody? Welcome to another episode of Lightspeed. Today, we're joined by Yannik from Elusiv and Jorrit from Light Protocol, which are two of the leading privacy protocols in Solana. Guys, welcome to the show.
Great to be here, Jorrit.
Pumped to have you guys here. Mert, he got the ick from Breakpoint. I think most people actually survived, at least from what I see on Twitter. There was no general sickness, but Mert doesn't have the immune system. So it's just going to be us three today. But I want to start with the idea that privacy is a prerequisite for crypto to have mass adoption. Why do you say that? What is the problem that you're solving with these privacy protocols? And then later we'll get into the details. And Yannik, maybe I'll let you start here.
Yeah, sure. So I think if we think about blockchains as this new way of having financial transactions on a distributed ledger, we need to look at the system that we sought out to replace with this new financial architecture, and that would be the traditional financial system. And if I send you money via bank transfer or PayPal, you will not be able to trace all of my past financial activity, what I spend my money on, what health bills I have to pay, or what kind of political donations I do. If we have the status quo public blockchains, that would, however, be the case. So I think starting from the most simple use case of blockchains, which would just be financial transactions peer-to-peer, there's a lack of privacy by default, and that's problematic for individuals because they require privacy for their autonomy to freely be able to spend their funds, but also on a larger scale, if we look at organizations that want to move their activities on chain, there's issues there as well. If all of your financial actions are publicly visible to anyone, but also if we move away from the financial aspect, the data of your users, the data of your company also cannot be publicly exposed. So I think privacy is core to a lot of applications, is core to the individual's autonomy. So that's why we need some sort of solution that goes beyond pseudonymity provided by hashes and public keys that cannot be directly linked to your identity.
Yeah, Jorrit, what about for you? What was the inspiration for starting Light?
The inspiration to starting Light goes back actually that I tried to build an application which very much needs privacy at its core, voting on Ethereum. Since your vote can be influenced by seeing the decision of other people, right? This is the minimum requirement that you don't want that, which turned out to be quite difficult. So after building it, I thought, okay, I want to build an infrastructure which enables you to build applications like this, applications for the real world, Yannik just said, for you already need privacy for the simple payments use case, right? But even for other use case, even more so, like voting, or for any business to go to do business on the blockchain, right? You have supplier relationships which you don't want to expose, as an example, to the general public. It can be actually a competitive disadvantage for you to expose this data. So I think there's a really big issue here, and like you stated in the beginning, I think really strongly believe that privacy blockchains will not be able to reach mainstream adoption without privacy protocols like we are building.
Yeah, I completely agree. Maybe we can touch on the history a little bit of privacy and crypto, because it is funny in some ways that the people that are initially attracted to crypto are in some ways people who want complete ownership of their data. They're maybe worried about where their data is going in servers and how it's being shared and not private. Yet blockchains in general are really all about transparency. You can read everything that's on the blockchain. We saw things like Zcash come out. That was actually at one point, I think some people thought that might surpass Bitcoin because it had privacy and like innate into the system. But that didn't work out. I mean, it's still around, but it did not replace Bitcoin. And you had Monero. So why do you think, and also Light and Elusiv just launched this last year. So I'm curious, why do you think this privacy bit has taken a while to maybe catch on, or what was holding Monero or Zcash back? Kind of just like the history of that.
Yeah, so I think, but what's also interesting, so a few weeks ago, I had some Twitter live space discussion about on-chain privacy at Mario Naval's Twitter space, and we were as guests going in there expecting some privacy discussion like we're just having, but it was really a privacy discussion about the host saying we don't need privacy, we want transparency because we are some sort of Bitcoin OGs that think transparency is key. So that was quite unusual because I think the more mainstream opinion really is that you need privacy. So Zcash has been one of the first full blockchains that have privacy at their base layer, and full privacy meaning both confidentiality, anonymity. And Monero, on the other hand, uses a bit of a different technology, but can be viewed as the same thing, I guess, from a high level. I think they haven't really taken off for multiple reasons. One big reason simply is that we have Bitcoin as this one, as the gold standard, as people like to call it. And the other applications like Solana or Ethereum really offering smart contracts to be built on their platforms to offer those general purpose blockchains. And I think that's a big difference to have those blockchains with the USP of saying we are a private blockchain versus other blockchains saying we are general purpose blockchains. And what we need to realize at the end of the day is that the end consumer doesn't care that much about privacy. If we have to tell the end consumer, hey, use our app instead of this app, use this blockchain instead of that blockchain, because we offer privacy, I think that's problematic simply because end consumers don't care that much about privacy, that they will go out of their way, choose a worse UX, choose a completely new ecosystem. And so I think that's one of the main reasons. Another reason I think has been, if you look at different legislators and different exchanges not accepting Monero or Zcash, simply this issue of compliance. That's simply the case if you look at, I don't know, dark web marketplaces only accepting Monero as their currency. So I think there is this connotation of illicit activity to some degree with those applications. And so I think if those apps this blockchains were to have this big mainstream adoption, we would see a lot of regulatory action to further prevent those blockchains to be used. So I think it comes down to user experience and compliance at the end of the day, I think.
I think another reason that's really has been holding back the adoption of privacy in blockchains is that the tech is actually really hard. Like Zcash is the first, to my knowledge, the first application team that really took zero knowledge, general purpose zero knowledge proofs into production. And the first implementation, the proofs were very slow. I think it took a minute to generate a simple spending proof, something that we can now do in a second, right, on a consumer machine. So there has been they have been pioneering the tech for years, and the tooling has really been maturing a lot over the last years. That's why we can now get into building higher level privacy tooling on chains like Solana, with which then can provide the UX so that users don't have to live with worse UX than they will have to with other chains, right? And I think the other thing is really that we need programmability to drive large-scale adoption, because the use case, like, to be honest, Bitcoin doesn't have that much adoption apart from having a big market cap, right? So this is like, based alone on privacy, it's difficult to compete. So you need these applications which are uniquely enabled by privacy, which really needed. And I think on the compliance side, you can build applications that are compliant. Like in Web 2, like, let's say, take an app like Robinhood. It does compliance for like the user in the application, right? It you can pay your taxes, you disclose your data to the authorities. I think crypto apps should act more in that way and improve UX for the user. And then governments are also going to be at ease with this, because this is something they know. And I believe that we can structure with free applications in this way on the surface, so that we have the best of both worlds and we don't face a regulatory backlash.
I think what's also important at that point, something that you mentioned with the 1 minute proving time on Zcash, just imagine when looking at messaging, right? Let's say end-to-end encrypted messaging would take you 1 minute to send a encrypted message to your friend, right? Nobody would be using end-to-end encrypted messaging. So we've seen this great improvement over time, and now are finally at a point where we can offer those applications. Almost seamlessly, I guess.
And one important thing for encryption is actually hardware support, right? And we're not even there yet at this stage with zero knowledge proofs. So you can imagine that in the future it's going to be even more seamless.
Jorrit, I know you've probably explained this 1,000 times, but at a high level, can you explain what a ZK proof is?
Sure. Yeah. I mean, like, at a high level, you can prove that you know something, right, without actually revealing the input data. So in more technical terms, you will generate a witness, which is your private input data, right? Then you will have some public input to actually tie your proof to something in the real world, like in most like privacy protocols like Zcash or like Light protocol. This is a Merkle tree which you have a commitment in, and then you can prove that, and to stick with the example with the Merkle tree, you can prove that you have a leaf inside this Merkle tree, right, without revealing which leaf this is. I involuntarily went pretty deep into a technical example there, but yeah, and like, the gist is that you have this wonderful technology which lets you prove that something that you know something without showing.
An example I think of, which I don't know if this is the best representative, but is like, if you wanted to get into a bar and prove that you're 21, you don't have to pull out your ID and they can see all your information, but you can. They just know that you're older than 21, but they don't know what your age is. And ZK proofs allow you to show that. And Yannik, I know, like, you both talked about composability, and that's one thing that with like Zcash you don't have, because there's not like an ecosystem built on top. And I think you've mentioned it would be like if you had, your friend or your mom go on a web browser, and there's HTTP and HTTPS, which is secure, which helps with encryption, keep your data safe. If you had to switch browsers to actually access HTTPS, people probably just wouldn't do it. But the sense that it's actually like built into the browser, it makes it really easy and essentially like composable. So I'd like to get into actually how Light and Elusiv work. And let's get into some of the technical details, but I really want to know like what it looks like from a user's point of view, like from the user's perspective. And Yannik, maybe you can start.
Yeah, sure. So I think it makes sense to just explain some similarities that both of us share. So you talked about zero knowledge proofs. Both of us heavily use zero knowledge proofs, and what we use is a special kind of zero knowledge proof, so-called CK snarks, which are just the gold standard, I guess, of zero knowledge proofs, at least from my perspective. With them being very compact, very fast to be verified. And so how we add privacy on-chain is basically we have in the zero knowledge proof setup, we have basically always two parties involved. We have the party involved that holds the secrets, that wants to prove something about the secrets they're holding, and we have the verifier. And the verifier is simply a smart contract on the blockchain or the blockchain itself. And what the user proves at the end of the day in their zero knowledge proof, and that's a similarity that we share, is some value in a Merkle tree that's on-chain. And we can realize this Merkle tree structure for the user to basically prove, just as you described with, I'm over the age of 21. What that at the end of the day is a proof that you're in the age subset of ages larger or equal to 21. In our case, that would be I'm part of the subset, or I know something out of the subset of all of the assets of all users, basically. And with that, we can create what's called a multi-asset shielded pool. So we have a smart contract that holds the assets of all users, and all users have some cryptographic data structures that are being stored on chain. And then the users generate zero knowledge proof, a zero knowledge proof about this encrypted data that is stored on chain, in order for those users then to be able to privately transfer those funds to other parties. So I think those are the similarities for us using CK snarks and multi-asset shielded pools, Merkle trees, all that kind of stuff. And I think so some fundamental differences. What we attempt with Elusiv, and that's something that I talked about a lot last week at Breakpoint, and also gave a keynote about, is what we call ZUS, Zero Knowledge Encrypted User Safeguarding, which is our new decentralized compliance approach to bake compliance into this multi-asset shielded pool, basically at its core, and have a rule-based compliance in contrast to, let's say, discretionary compliance that would rely on the user to become active. So this built-in decentralized compliance is a big part of our vision. And then also the way we go about moving or adding privacy to applications. So we started off with basically allowing for private access to public applications. Basically, at the end of the day, adding an incognito mode to your wallet, adding an incognito mode to your on-chain activities. I guess what you guys mostly focus on is really private execution. So to have this private state by default versus allowing this private access to public applications. And I think why having this private access to public applications is so powerful is simply because we have this heap of public applications that need privacy, or rather the users need privacy when interacting with them. But we cannot just shift all of those applications at once to become fully private, to rethink their architectures in a private way. Instead, basically going in at the entry and exit points of those smart contracts. And by that allowing a high level of privacy. And so we allow that with our Elusiv SDK. I think we can maybe talk about that on later stage, but that might also be too much. But with our MPC architecture that we are designing, what we're also looking at is adding autonomy basically to private applications. So if you have a private state application that allows the user to execute that application using a zero knowledge proof, I think a significant missing piece is having autonomy in that system. Let's say we are thinking about some auctioning system where we don't want, if the auctioning process has ended, some party to manually have to claim something. We want to have some sort of autonomy, and I think having homomorphic encryption and multiparty computations that we utilize with our SUS network can add this additional component to privacy. So to boil it down, build in decentralized compliance and also private access to applications.
Yeah, no, it's to like get out of the weeds just for a second to make sure people that are normies like me understand all this. I have just like a few quick follow-up questions. So when you talk about compliance, for example, at a high level, would it be like, I'm going to a bank, I need to get a loan for my new business, whatever it is. They need to see, for whatever reason, some of my transactions, my balance, et cetera. But maybe everything's been done through a privacy protocol like Light or Elusiv. And I need to prove to them that I have some amount or I've made certain transactions. There is still a way for me to essentially, is it like take a receipt or whatever it might be from the privacy protocol and prove to the bank like, hey, I actually made these transactions. This is my account balance. Is that what you mean? Almost.
Yeah, sure. Yeah. So yeah. I mean, that's what also has been possible with Tornado Cash, I guess. This level of compliance. So that's what I would call, or you would normally call, discretionary compliance measures. So it's up to the individual's discretion to share information about their private state, right? So I guess that's basically also the core of what privacy is about. It means you have ownership over the data, and it means you can share your data with third parties. So you can share your data with a bank, generate a zero knowledge proof about your data, and prove something to the bank. That's one part about compliance, but the bigger problem that we are trying to resolve really is the issue of illicit finance in those systems, I guess. So that's really the pressing issue, and that's also what regulators and legislators fear the most are illicit financial activities. And we've seen big growth actually in illicit finance on chain. And if we want to go mainstream as this technology, and we want to mature as an ecosystem, I guess we need to find some way to combat that. And also, if we think about some of the initial core principles of blockchain, right? This transparency, where we said, okay, finally we are able to beat the corruption the traditional finance system has. Finally, we can beat the opaqueness. That's great, but also comes with risks involved. So I think we need to be honest about potential risks and need to find a way to resolve that without having to rely on any centralized actors, right? So I think that's actually a huge opportunity to build those systems and then educate regulators about the potential to have some sort of self-regulation that is permissionless and decentralized. So that's really what we are trying to do on a day-to-day basis.
Yeah. And Jorrit, I'd love to hear a little bit more just from your end with Light Protocol. And one thing maybe to touch on that'd be useful is thinking through, like, if I was a new user on Solana and I'm using Phantom, is like maybe, Yannik mentioned incognito mode, where I either want to send a transfer to someone, or maybe I think with Light, I want to take out a loan with a, lend and borrow protocol. What does that look like even from my wallet? Like, do I need to go to a, Light's homepage and say I want to make this transaction? Or is the ideal end goal is just I'm in my Phantom wallet, for example, and I hit like incognito and the transaction happens privately?
So the absolute end goal is that you have this built in your wallet. Your default transaction is private, and if you can just, for you, it feels like interacting with any other DeFi protocol on Solana, right? You shouldn't have to hit incognito mode in the first place. I think this is like one step too many. If something is opt-in, most people are not going to use it, right? So I think this is the approach we are going for with Light Protocol, to really have this default privacy, default private applications with ZK execution. For some applications, you will want to leave that. You will not want to build them in ZK. For example, like really scale, like high frequency order books, like you will still have to delay like additional overhead from the ZK proofs, right? You might still want to build that in normal Solana smart contracts. But like, for example, taking a loan, right? This is like process which is not being conducted a lot of times. Like, it's okay if there's a bit more overhead involved. And so I think that's a pretty good example, which would actually be pretty straightforward to build with the technology that we have built now today. Actually, maybe let me get into that as well, like what we've actually built. So, like, I think Yannik already talked a lot about the similarities, right? It boils down to, you have the circuitry on chain, you have the verifying like contract which verifies your snark proof on chain. I believe both of us are using Growth 16 proofs right now. What we have, you have your multi-asset shielded pool. So what we've added to this is the possibility that you build your PSP on top of this, which means adding your custom logic proof on top of your shielded pool transaction. Sounds more complicated than it actually is. It is really like, if you look at it, you really just like declare essentially the data that goes into the proof, right? And then you say, okay, for a loan, for example, I want like certain conditions to be met, and you define them there in your PSP. Like, if you are an Anchor developer, you can like, it will take a bit of time. You will chew glass, but it's possible for anyone to build this, for any Solana developer to build this.
And Jorrit, when you say PSP, you're talking about private Solana programs, right? Is that what that stands for?
Yes, exactly. So this is our programming. This is our execution environment. Private Solana programs. You're building a Solana program which has its logic defined in a zero-knowledge proof circuit. So what it does essentially is it takes the computation, instead of usually being on-chain, right? The Solana consensus makes it trustless, that your computation is it's deterministic and trustlessly executed on chain. The zero knowledge proof enables you to execute your computation off chain. This is also how you achieve privacy, and then verify this computation and disguise your custom PSP, private Solana program logic, on chain. This is a really, really powerful primitive, which is in particularly very well suited to work with account compression, because account compression actually stores your data in call data, and not in a PDA, not in an account on Solana. So the data is not accessible on chain. You just have committed to this data on chain. But with ZK proofs, because your computation is happening off chain anyway, you don't have to send the data on to the chain. As you just have your data off chain as well, so it goes very well too.
How realistic is it? Like, do you think in the future that the majority of transactions are going to be private by default? And if that is the world that we end up at, I'm curious. Like, one, how long you think that would take, and then two, this is kind of random, but do explorers just like fall apart? Because right now, like our analysts are on explorers all day, like tracking transactions, tracking what's happening on with Uniswap. Does that just implode, or what's going to happen?
I mean, there will still be public state, right? There are still plenty of applications for which you will need private stake. So explorers will still be like exist in a different form. But yeah, it's an interesting thought, right? To actually see your own transaction history, that you will need to go to your wallet, not the explorer, right? Which makes things a bit different.
That's also so interesting about I guess both of our projects building on Solana. Really, this thesis of having some sort of a hybrid, to what degree that might be, between having super fast public transactions, having not as fast, but also, I guess, compared to other chains and proof verifiers, super fast proof verification. So to have this, private and public general purpose chain, I think, is really the future we are heading to.
Definitely. And to go to your second question, like how long will this take and will it be feasible? I very much think that it's feasible. I mean, in the past, if you look at other emergent ecosystems, right, for Solana itself, until it like how long it takes to get traction. I mean, it's probably in a number of years, right, until you get really like a really big established ecosystem based on these. Yeah, we are in the early beginnings, but I'm very excited and optimistic.
Quick break to tell you about an upcoming event I promise you don't want to miss. It's Blockworks' biggest and best institutional conference called DAS London. It's a 2-day event happening in London this March, where we're going to have over 700 institutions, 130 speakers, and a couple thousand of us all under one roof. Crypto is in a position for the first time to actually onboard these institutions, and they're showing up. We have companies from BlackRock to Visa launching real products in the space. We have the real world asset narrative taking off. We have things like payments that have been exponentially growing. And then we have things like DePIN happening in the Solana ecosystem. There's a ton of capital right now in this institutional space. It's going to be coming on chain. It's going to completely change the industry. Whether you are an institution or you're a retail user, or you just want to learn more about what's going on in the space, this conference is for you. You're going to be able to meet some of the best and smartest people in the space. The speaker lineup's absolutely incredible, and you'll get to hang out with me. But the best part is you actually get 20% off your ticket if you use Lightspeed 20 when checking out. That's Lightspeed 20. I put a link in the show notes. I recommend buying this today because, one, you'll forget about it. Two, these ticket prices go up every single month. So anyways, I hope to see you there. Now let's get back to the show. Is this where using standards, I would assume, help across protocols? Because like one thing with Ethereum, and you have rollups, and you have all these bridges, and you have validating bridges, and you have ZK proofs coming into that. And one big question is, yeah, great. These bridges will be wonderful if they all work perfectly and there's no bugs in there. But the more bridges you have, maybe, the more bugs and vulnerabilities there could be. If I think of like 90% or 50%, whatever it is, of transactions on Solana are private, does that add like a big risk surface area, or is it using these standards that are well tested over time? Like, how do you see that playing into this? Because as just like, if I imagine myself at like Bain Capital and I'm just like, oh, they're adding this complicated ZK solution on top of Solana, like, is this actually going to affect some type of backdoor bug?
It's actually, I think our tech is relatively simple in comparison to these bridges, for example, which like if you bridge between blockchains, you have incompatible execution environments. You're doing like complicated things to get around these constraints. So, and also a lot of like these ZK proofs in particular, they get really big, really complicated. It's a lot of code. Like our circuits, like the logic defining our ZK proofs is in the hundreds of lines of code. And it's written in Circum. Probably most of you will not know what Circum is, but it's like the most established and tested DSL to write these circuits. And the proving system we've built is from 2000. We are using is from 2016. It's the gold standard of zero knowledge proofs. So I wouldn't. I don't see. Of course, you're building in a different environment. We still need to learn, but it's the attack surface is not like remotely as big as for bridges.
Yeah, and I think that's a good point actually. If we look at those circuits that we use, if we have those compact size circuits, but I think it would even be the case for larger size circuits if they are compartmentalized. What we can do is formal verification, for example, and at the end of the day, those arithmetic circuits are quite simple logic consisting of additions and multiplications. And so I think having some fixed static circuits that have been audited, tested, formally verified, I think doesn't really increase attack surface for the blockchain. Simply like it doesn't increase attack surface for the blockchain if some new system program were to be added, and that system program has a thorough process of, again, auditing, formal verification, and public development. So I think that shouldn't be the biggest fear. Of course, we need to be cautious because, again, those circuits can also lead to new kinds of bugs that one might not have anticipated, since it's a new environment. And I think at the end of the day, since this area is also being developed by, I guess, experts, cryptographers, it's not the day-to-day developers that touch this cryptography. So I think if you're cautious, we should be fine.
That makes sense. One more, like from a user standpoint, like MarginFi right now, I could take out a loan on Solana. Would MarginFi essentially have to like integrate with Light or Elusiv or protocol solution, or to more be there needs to be a protocol built from the ground up within something like Light or Elusiv, where that loan that I'm taking out can be private?
So so basically there's multiple layers to that. If we want the most simple, easy integration, how it will look like for us would just be you at the entry point using the Elusiv SDK. So that could be the MarginFi user interface, that could be your wallet. Any entry point from your assets leaving the shielded pool, entering MarginFi, and then from MarginFi again entering through the SDK the shielded pool. That would be the most simple solution that wouldn't require MarginFi to redevelop their whole protocol from the start. And then taking it a step further, that would then require this protocol to become fully private. And the question is that reasonable? Do we want that from a user's perspective, also from a protocol's perspective? I think Jorrit mentioned that earlier with high frequency trading, for example. So if we look at something like Jupiter Orca, those kinds of applications, what we would have to do is to build a completely new private order book to have all of that private liquidity, then have some automation, most likely then using multi-party computations in place, which all at the end of the day will result in lower frequency trading. And so the question again at this point would become, is privacy important enough for users to sacrifice this previously had user experience? So I think for such applications, it's very advantageous to simply have this entry and exit logic, you can think of as sandwiching at the end of the day, right? So you have a single Solana transaction. First instruction would be you getting your zero knowledge proof verified in the Elusiv program, and then your funds leaving the Elusiv shielded pool or calling an instruction in MarginFi, and then the funds you get from that basically exiting MarginFi, and in the last instruction being publicly inserted again into this asset pool into your private balance. So what would be publicly seen is that someone took out a loan of a specific size. That would be the details visible at that point, which I think would be reasonable to have. Yeah.
Mm-hmm. So the issue I see with and the reason why we don't like follow this approach by default is that what you do then is you offload the you offload the responsibility to be private pretty much to the user, right? Because and the more information is visible on chain by the user, the easier it is to see to put the pieces together and match patterns and see like who is doing what. And in theory, I think everything like this sandwiching could work great, but in practice, users will just enter a privacy protocol and then take out a loan immediately, right? In this case, you see the input traffic into the protocol, then the exact same amount.
But that would basically be the case if all you were to do is use that privacy protocol for that one application. But having the privacy protocols SDK, as I stated, for example, be at the user's fingertips in the wallet or in all of the user interfaces, that wouldn't be an issue anymore, because then you would have, instead of your wallet, the multi-asset shielded pool that is then being used by all of those users. So I think you're right with this approach not offering the same level of privacy that, basically having fully private state does. But I think what's important to realize is that, especially if you look at things like Alio or Aztec, there has been this issue, I think, in this privacy space of building in a vacuum and basically building just to build and not considering that we actually need adoption and need to gain attraction. And so we need to align those things in some way. And I think it's not the right solution all the time to simply provide a completely new framework for developing things. Because then at the end of the day, you also outsource then basically the adoption to, you MarginFi, please rebuild your application privately. If we say MarginFi, please add this SDK, which allows the users to access your protocol from the existing shielded pool that they already use, I think that can be a reasonable solution in between, and more long-term, we can shift to fully private state. But I think it's just takes time, as you outlined earlier. It will take time until you reach this point where everything is private. So we need to successively, step by step, move towards that stage.
But you just say yourself, like it takes time to get this adoption. So this is also the time where it's very easy for the user to reveal themselves because of unsafe user patterns, right? I mean, this is the same point I made before. Like the more like public stake you have, the easier it is to match patterns. So that's why we're going for the approach that by default, as much as possible, should be as private as possible on chain. This doesn't mean that the approach, for example, I don't know the Margin5 protocol very well, apart from that it takes loans. So I don't know if it's the exact right application to build with private state, right? Some applications, for some application makes sense, for others it makes less sense. And in the beginning, private applications are going to be built with private state, which are actually being uniquely enabled by private state. For example, an interesting example, there are certain games, right? For example, games which rely on on fog of war, right? That you don't know everything that's going on the map, which is right now, if you need a private state tool for something like this, right? And this is something where it's not possible right now to build a fully on-chain game with this.
That's actually a good point. On-chain games with private state, and that's also where that's with our MPC network, that's something that we've been looking at, right? So you have this let's say fog of war kind of scenario where every player encrypts their location, and you have this cool setup where now the user can prove to be at some location on the map. Now, if you have multiplayer applications, that becomes more difficult, because now you basically want to say, okay, under certain conditions, I want to autonomously reveal the location of one player to another player if they are in close proximity. So I think for things like that, then we need to look at FHE and MPC. So things get complex quite quickly, but those systems enable completely new kinds of applications at some point within the next few years. Whereas right now we need to trust, let's say, gaming companies to run their servers and not take down their servers. We can at some point maybe get fully autonomous worlds that use CK and MPC and homomorphic encryption to add ownership, even in such scenarios, back to gamers, I guess. Yeah.
To jump in real quick, and I think I'll probably need your guys' help on this, but I'm going to try to explain this to the listener. When you say homomorphic computation, there we go, I was able to say it.
Encryption,
at a high level, right? That's essentially, let's say you're able to do computation on encrypted data as if it wasn't encrypted, but it's never actually revealed.
Exactly. So if we compare MPC and homomorphic encryption, so I think homomorphic encryption basically means you have your data, you encrypt that, so it's in an encrypted representation, and then you perform arbitrary computations on that data, which again yields some data in this encrypted representation. Then the owner of the data could decrypt it, and it would be the same result as if the user just performed those computations on the unencrypted data. So that means this computation can now be outsourced. So the user doesn't have to perform those computations. Instead, a smart contract, for example, can run those computations without gaining knowledge about the data. So something like this can add confidentiality to execution. Multiparty computations can, on a high level, be viewed as a sort of zero knowledge proof in themselves. But instead of just having a prover that wants to prove something to a verifier, we have multiple parties that want to prove something, basically. And proving something means, at the end of the day, perform a computation. And the caveat now is that those parties mutually distrust each other. So each of them holds a private key, and they want to, or I think the simplest example would just be, we have 10 employees who want to compute their average salary, but none of them want to share their actual salary with each other. So that would be a classical multi-party computation use case. And so what they do at the end of the day is they use their own private values to generate a sort of proof, which then proves, okay, the average salary is XYZ. And so all of them are happy and can verify that the output is correct. So that would be MPC. I think the interesting puzzle piece here is that if we apply homomorphic encryption, or more specifically FHE, so fully homomorphic encryption, we can perform any computations on data, but the data still needs to be decrypted, I guess, by the corresponding owner of that data. And with MPC, we can do things like threshold decryption, threshold encryption, and can distribute data ownership into, again, a large distributed network. And so combining both, we are able to run arbitrary computations and then under some algorithmic conditions reveal something about the data, expose some of the information, which I think is interesting, as I just outlined with this gaming example, using it for something like this.
Maybe to expand a bit on that, I mean, it's super interesting. One thing to add there is that this technology is still like in the very, like maybe where ZK in general was 5 years ago, I would say. Still like homomorphic and fully homomorphic encryption is still very early and very difficult to use. So I see approaches like this are a bit further out in mainstream adoption, or like than ZK proofs like we are using in the private Solana programs.
Yeah, totally agree. So, B basically, if I dive into some of the technological stuff, so MPC basically has been around since forever, at least feels like that, in the crypto space, and for our multi-party computations, we actually use homomorphic encryption in the multi-party computations, and there's a multitude of different kinds of homomorphic encryption. We have different phases in the MPC, so we have one single initial setup phase for the MPC, and in that we use FHE, which is inefficient. We also use zero knowledge proofs for that, but for the initial setup phase, for the key generation phase, that's not an issue. And then for the actual execution phase, what we are able to use is so-called somewhat homomorphic encryption, which basically means it's not fully homomorphic encryption. It's only allowing additions to be executed homomorphically and multiplications not. And so there's this balancing act between technologies to make the execution as efficient as possible with, as Jorrit said, the tools that are available at this day and age in an efficient way.
Yeah, those explanations helped a lot. I know the average retail listener like me is probably going to need to listen to this 3 times, but the analogies and everything are very helpful. We're coming up on an hour, but I'd like to pivot onto one more topic before we go on. And Jorrit, maybe we can start with you. I'm just thinking, I know Solana just launched a new token program, or it's like coming out in phases, token 22. And token 2022, and they have confidential transfers, which adds some type of privacy, not into necessarily the base layer, but the Solana program library. But my bigger question is really, like, as a developer working on privacy in Solana, or even like any type of what people would call monolithic layer, do you ever feel like you're held back by the lack of features, maybe at the base layer, or some type of precompile that would make cheaper transactions? I know in Solana everything's so cheap anyways right now that doesn't matter. Is there a use case to say like, hey, we actually need like a rollup or a layer on top of Solana because we can't do everything we want to because the base layer is not moving fast enough to support our privacy features that we need? Just curious, like, how you think about that at a high level.
Great. I mean, you touched on several things there, right? So token 22, like with the ZK token, is super interesting, but like different from Light Protocol and Elusiv, since It has confidential transfers. It's like some interesting mix of bulletproofs and homomorphic encryption, which like is maybe enough for some use cases, but you can still, like, you work with encrypted values on chain and you see them changing. So you see like essentially who interacts with whom. So for example, for payments, like imagine you pay at a gas station, right? And you could essentially track the user, because you see at which gas stations the user has paid, right? So this wouldn't be enough for a payment use case like this. For other use cases, maybe I've heard that somebody's working on settlements with this, which might be fine, right? If only the transactions are private. Different part about the rollup part. Yes, we have been. I'm very excited about the precompiles for the AltBN 128 curve we have been building as a syscall into the Solana runtime. It got merged like pretty much a year ago, and it's going to make the verification of zero knowledge proofs a lot cheaper than they are now. Even though Solana is so fast and cheap, verification of zero knowledge proofs this time on mainnet is still very expensive. It will take you tens of transactions to actually get like zero knowledge proof verified. So the Light V1 right now, which is live, is not as fast as we would like it to be. So this is why we went at the like very bottom level and built these precompiles, which will allow you to verify a zero knowledge proof in less than 200,000 compute units. So one atomic Solana transaction will enable you to verify a zero knowledge proof. So Light V3, which will launch as soon as the precompiles go live, hopefully in 1.17. So right now it's scheduled for beginning of February, if nothing changed. In the past, it has changed a couple of times, so I really hope.
Jorrit, how would you describe a precompile to like a non-techie?
So it's really it's a piece of code that's that's directly built into the Solana runtime and has like in the Solana runtime is a virtual machine, right? So the how expensive operations are is in like on a high level, it's arbitrary. I mean, of course, in reality, it's not completely arbitrary. Otherwise, these operations still are executed on hardware. They will cost you something. So this is a special piece of code for which different rules apply. So there's a specific price set to execute this operation, and it's built directly into the runtime. So this makes, and then like the jump guys with higher dense are going to lengths to implement this on custom hardware, really optimizing the implementations there to make it more efficient. So it's just a different piece of code in the runtime for which different rules apply.
Gotcha. And because of that, like you said, you could get cheaper, like these proofs could be much cheaper to prove, for example. Cool.
Exactly. Yeah. And so this is the verification precompile is one with which we have built. We also, like we mentioned a couple times before, we have a Merkle tree, right? For a Merkle tree, you need hash functions. Unfortunately, we cannot rely on the standard hash functions because they are very inefficient in zero knowledge proofs. So we've built an additional precompile for the Poseidon hash function, which is the standard hash functions, which is used in conjunction with zero knowledge proofs on Groth 16. So this one is also in 1.17. So we hope that this one is also going to go live soon after. So with these two precompiles, one basic light asset transfer is going to be in one transaction, one Solana. So one is going to be one shielded transaction equals one Solana transaction. This really eliminates the need to build rollups, fortunately. which we are very happy about because it adds a lot of complexity, and like issues with composability, as probably many people are aware of. So it's really not necessary to build rollups, and if you will, I actually, like, compressed accounts are actually pretty similar to rollups on Ethereum, since you put the data on chain and for data availability, but and with ZK and compressed accounts, you essentially put the execution also of chain. So you could, in some weird way, say that PSPs are rollups which just settle directly on Solana. But yeah, it's where these technologies kind of like intertwine, and it's just solving different problems because we don't have to solve for scalability like people need to do on Ethereum. So
and I think that really ties into why both of us are at the end of the day also building on Solana. It's this ecosystem that is fast moving, has this openness to new technologies, even at the base layer, simply by Solana wanting to be as composable as possible. So we don't want to have some external settlement. We want to have everything happen on the base layer. So I think that's a very powerful characteristic of the Solana ecosystem, I have to say. Yeah.
Awesome. Those are great answers. Jorrit, Yannik, it's like obviously the stuff can sound really complicated, I think, to like the average user, but I think it's also easy to realize like how much we need privacy. I was just talking to somebody in the office, and you're applying for a New York apartment, and you have to give your like financials, and they have to make sure you make enough and so forth. And you're basically handing over your life to someone that you have no idea who they are. And if you could use some type of, ZK tech or proofs, it could really be game changing. And also just protect your data in ways that you don't know what it's being used for now. So I think everybody can relate to that at least. So guys, thank you so much for joining. I'm going to put links to your projects in the show notes. Everybody should go check it out. But yeah, guys, it's a lot of fun.
Yeah, thanks for having us. It was a lot of fun.
Likewise, thanks for having us.
Sweet. We'll see you next time. All right, I've got a little ending note here. First, thank you so much for listening to the full episode. If you really liked it, hit subscribe. But secondly, make sure you sign up for DAS. This is Blockworks' biggest institutional conference happening in London in March. I've included a link in the show notes and also a discount code. Get 20% off. Make sure to use Lightspeed 20 when you sign up. All right, I'll see you there, and I'll see you next time on Lightspeed.